The remainder theorem is just another way of figuring out the solution to a function. So here is the substitution of a function. So the way we've done it before is we've just substituted the 3 into this function. So if I go through that process and go 3 squared and then do 3, and all I'm doing is substituting into the function and do the math. This is 27 times 3, which is 81, and this is 9 times 6, which is minus 54, plus 3 minus 11. If I do that math, I end up with 19. So the f of 3 function equals 19. Now that's how we've done it before. What synthetic substitution is using synthetic division and doing the problem. So if I do synthetic division like we've done before, I put my numbers in order. If we continue with the synthetic division, we would get these numbers. And so here's the process again. We drop down the first term. We take 3 times 3, so 3 times 3, which is 9. We then add 9 and 6. We do the same thing here. We 3 times 3. We add 9 and 1. Once again, we take 3 times 10. And we add 30 and negative 11, and we get 19. This last number has always been the remainder. So the remainder theorem basically says that when we do synthetic division or synthetic substitution, the remainder is a solution to the function. So if you look back up at the beginning when we did this problem of f of 3, we got 19. We also have the remainder of 19. Alright, so let's do this process again. I'm going to substitute f of negative 1 into this function, and when I do that, I have 4. I have negative 1 to the 5th power plus 2 with negative 1 to the 3rd power plus negative 1 squared minus 1. So when we do the math, this would be a negative 1 times 4 would be negative 4. This would be a negative 1 times 2, so that'd make it a negative 2. This would be a positive 1, and we have a negative 1. And if we do the math all the way through, negative 6, this is 0, so my answer is negative 6. So what I want to show you is that it can be done in the way we've done it before. But if we do our synthetic division that we've also used and try to do the problem, sometimes it's a little easier. So if I put my negative 1, which is what we're substituting, nothing changes when we do this kind of substitution. And now I'm going to put my numbers in. And here's where we have to remember to hold whole place values. The 5th power, I have 4. But next to the 4th, I don't have anything, so I have to put a 0. 3rd power, I have a 2. 2nd power, I have a 1. And 1st power, I have nothing. And then to the 0 power, I have negative 1. So I had to use, for x of 1 and x of 4, I had to use 0 as the whole place value. And that's the only tricky part of synthetic division. So I have that taken care of. I then go through the process again. Drop down the 4. I multiply negative 1 times 4, which is negative 4. I add. I then multiply again, so I get a positive 4. I add 6. I multiply, I get negative 6. I add negative 5. I multiply, I get 5. And when I add, I get 5. And when I multiply negative 1 times 5, I get a negative 5. Negative 5 plus negative 1 is a negative 6. Now what we did before is we put our variables and made our polynomial. In this case, we're using just the remainder because the remainder is the solution to the function, as you can see when we first did this problem with substitution. So negative 6 is the answer to substituting into the function.